All right, these are the answers to page 356. For 34a, we're trying to find the equation of the tangent line. So we'll take the derivative, which will be e to the 2x. So the derivative of e is just its own thing, so we're going to repeat it, and then times the derivative of the exponent, which is 2. So if I were to put 0, 1 in for this one, I'll get e to the 0, which is 1. 1 times 2 gives me a slope of 2. And so I get y minus 1 equals 2 times x minus 0 for that equation. Over here, this derivative would be e to the negative 2x times the derivative of that, which is negative 2. So now when I put 0 in there, I get e to the 0, 1. 1 times negative 2 gives me a slope of negative 2. And so now I get y minus 1 equals negative 2 times x minus 0. So very similar, just negative 2 instead of positive 2. 36, we're looking for the derivative there. And so again, when you take the derivative of e, it's just going to be its own thing, own derivative. So we repeat times the derivative of the exponent, which is negative 2x. For 38, it's going to be a product rule. So derivative of x squared is 2x, leave e alone, plus x squared times the derivative of this, which is e repeated, times the derivative of negative x, which is negative 1. That negative could be put here, made that a minus if you wanted. You could also pull an x and an e to the negative x out of both of these and write what's left over. Sometimes the AP will do that, sometimes they won't. It really just kind of depends. For 48, if we take the derivative of this is that second fundamental theorem. The derivative of an integral is going to cancel. You're going to take this e to the 2x, drop it in place. So we're going to have natural log of e to the 2x plus 1 times the derivative of e to the 2x, which is e to the 2x times 2. For this one, we're looking for the equation of a tangent at 1, 0. So dy dx is going to be product rule, 1 times e to the x plus x times the derivative, which is still e to the x, minus the derivative, which is e to the x. So if we put 1 in, we're going to get, so dy dx at x equal 1 is going to be e to the first plus 1 times e to the first minus e to the first. So we're going to get just e for that. That's our slope. This is our point. So y minus 0 equals e times x minus 1. There's our equation of our tangent. 62, we're looking for the derivative here. So it's the derivative of the square root of x, which is 1/2 x to the negative 1/2. Plus, then the derivative here is going to be a product rule. So derivative of e to the x is e to the x. Leave natural log of x alone. Plus, now leave e to the x alone times the derivative of natural log, which is 1 over x. So that'd be our answer there. Now, 86, through the rest, we're integrating. So on 86, I see I've got negative x to the 4th. That's in the exponent. I want that to be the u here. Du then will be negative 4x cubed dx. That means dx is du over negative 4x cubed. Come back over. This is going to be the integral of e to the u times negative 4x cubed times dx, which is du over negative 4x cubed. The negative 4x cubes drop. So I end up with integral of e to the u du. Now e to the u is its own derivative, therefore it's its own integral. If I get e to the x or e to the u or e to the t, it always is going to integrate back to itself like that. Okay? It's got to be a single variable. It can't have e to the 5x or e to the x squared or anything like that. If it's a single variable, it'll always go back to there. And then the last thing we can do is put that negative x to the 4th back in. And then there's our answer. Okay? So same idea here. I see this 1 over x squared here. That's going to be our u. And so du will be, this is x to the negative 2. So du will be negative 2x to the negative 3 dx. Now if I rewrite that, that's negative 2 over x cubed dx. So if I multiply, divide by negative 2, I get that for my dx. All right, so I come back over here. I'm going to have e to the u now over x cubed times x cubed over negative 2 dx. The x cubes drop. Pull the negative 1/2 out. E to the u du. All right. And then again, that's going to integrate to e to the u. If I do the substitution, it'll be e to the 1 over x squared plus c. So whatever, if I have an integral with e to some kind of complicated exponent, that's going to be your u. It's an automatic u sub, make the exponent equal to the u. Right? We get 99 here, and I see negative 2x. Let's make that the u. It's possible to go through this without having to do that. This is a u sub, but we'll just make it that way. So dx is equal to du over negative 2. So come over here. We're going to have e to the u times du over negative 2. And these were x limits. So if I put those in for x, I end up with 0 for this one and negative 1/2 for that one. And we'll stay over here now. So pull that negative 1/2 out. This is going to integrate to e to the u, and we're going to do that from 0 to negative 1/2. So if we do that, we'll get negative 1/2 times e to the negative 1/2 minus e to the 0. And that e to the 0 is 1. So if you want to write that as 1, that's fine, but you can't get rid of it. We have to have it in there. It is part of this. This would be our answer here. So similar idea here. I've got e to the x cubed over 3. We're going to do a u sub. Let's let x cubed over 3 be the u. So du will be 3x squared over 3, so x squared dx. So dx will be du over x squared. So come back over here. We've got x squared e to the u times du over x squared. The x squareds are going to drop. So this is going to be good, but let's stay in u. So these were x limits. Let's put them in. Negative 2 cubed divided by 3 is a negative 8/3. 0 cubed divided by 3 is 0. All right, so this integrates, this e to the u du integrates back to e to the u. We're going to do that from negative 8/3 to 0. And so we're going to get e to the 0 minus e to the negative 8/3. If you want to write that as 1, that's fine, but again, you can't get rid of it. It's part of our answer. All right, so that's page 356.